So let's first begin by defining what a matrix really is. So a matrix is a table of numbers arranged in rows and columns, as we can see over here in the picture. We denote matrices by capital bolded letters, and whenever we need to access an element within the matrix, we need two pieces of information. We need the row number and we need the column number. So this element over here would be the element in the first row and in the first column, hence the name little a 1, 1. This element over here would be the element in the first row and in the second column, hence the name A1, 2. What we notice is that these subscripts over here denote the row and column number of a particular element. Namely, the first subscript denotes the row number and the second subscript denotes the column number. Pretty straightforward. The first matrix operation we're going to cover is matrix addition and subtraction. Whenever we perform such an operation, we need to have in mind these pieces of information over here. First, the matrices must be of the same size, and by that I mean the number of rows from the first matrix must match the number of rows from the second matrix, and the number of columns from the first matrix must match the number of columns in the second matrix. Therefore, here we have a 2 row by 2 column, and here we also have a 2 row by 2 column matrix. Therefore, matrix addition or subtraction can be performed. As far as carrying out the actual operation, all you need to do is just add or subtract the corresponding matrix element. So here, in order to get this first element, I just add the corresponding elements. 1 plus 1 gives me 2. 3 plus 1 gives me 4. And so on and so forth. And as we can see, the resulting matrix will also be of the same size. Same number of rows, same number of columns as the matrices we are adding. Now, what if we have something like this case? Here we have two matrices of different sizes. Can we still add them? Well, not really, because like we said, they have to be the same size. Otherwise, this doesn't make any sense. But what I want you to remember is this. Whenever you attempt to perform some computation in a program, the program doesn't really know what you want from it. You will just spit a number given you put enough information, and you won't look any further to see if it makes sense. Therefore, it's up to us as engineers to interpret the results that programs and machines give to us. So keep that in mind when we get into the Excel demonstration portion of the course. Next, we're going to tackle matrix scalar multiplication. Well, we use this to scale a matrix by a certain factor. It's very easy. For example, here we have a scalar, number 3, and we're scaling this 2 by 2 matrix over here. And to do that, we just multiply each element by the scalar factor. So 3 times 1 gives me 3. 3 times 5 gives me 15. And slightly more trickier, but nothing we can't handle, is matrix multiplication. Now, matrix multiplication is a bit tricky because we have to make a different type of check before we can proceed. And that is as follows. The number of columns of the left matrix must match the number of rows of the right matrix. So here's what I mean. In this example, we have a 3 row by 2 column matrix, 3 row, 2 column matrix, multiplied by a 2 row, 2 column matrix, 2 row, 2 column matrix. And if you notice, the number of columns from the first matrix, which is 2, matches the number of rows from the second matrix, which is also 2. Once we have that out of the way, we know we can perform matrix multiplication. So another question that might naturally come is, what is going to be the size of that matrix? And that is simply the two numbers here we haven't used, 3 and 2. 3 rows, 2 columns. 3 rows, 2 columns. As far as carrying out the actual operation, we proceed as follows. Now, I went ahead and highlighted some of the entries to see what is actually happening in the multiplication. So first, let's see, 1 times 1, and then we multiply 3 times 2, we add those up, we get the first element. Similarly, to get 11, which is the element in the first row and second column, we simply repeat the previous operation. 1 times 2 plus 3 times 3. But notice that we shifted over a column in here, right? We add those up, we get 11. To get the next element, now you need to go a row down and repeat the procedure we just did. Pretty straightforward. Now a trick question. Can we still perform this matrix multiplication if we were to swap the order these two matrices were multiplied? In other words, can we perform this multiplication over here? Well, let's check the first condition. This is a 2-row by 2-column matrix, and this is a 3-row by 2-column matrix. Since the number of columns in the first matrix doesn't match the number of rows in the second matrix, matrix multiplication cannot be performed. And finally, the last operation we're going to look at is the transpose of a matrix. We denote transposes by a superscript capital T letter, and it is an operation that switches the row and column indices of a particular matrix. So here we have this matrix A, and if you want to get a transpose of it, you would simply just swap the rows for columns. So 1 to 1 becomes a row. Here it's a column, here it becomes a row. 379, here it's a column, here it will become a row. The transpose of a matrix is one of those operations that I'm pretty sure whenever you come across it the first time, it doesn't really make as much sense. Why on earth would you swap the columns and rows in this particular manner? And to satisfy your curiosity, I would say that it does have some applications. Now, whenever you get to your senior or junior year classes for your engineering courses, you will most likely come across some form of matrix analysis to solve for forces and stuff like that. And you will see that the transpose actually makes sense to use whenever you have elements at an angle. Now, another example could be data processing. Say you have an application that reads information in a particular way. Now, if I have my data in this manner, or you might not be able to read the information the way I want it, but by performing a transpose operation, I can have that program read those data nicely and do what I want it to do. So having that said, let's jump into the Excel demonstration part of the course.
Alright, welcome back everyone. In this part of the video tutorial we're going to look at how we can apply the concepts we just reviewed from the PowerPoint into Excel. Alright, so the first thing in our list is matrix addition and subtraction. To perform matrix addition in Excel, all you have to do is simply locate where you want to display your answer, click on that particular cell. In this case, I also like to put some sort of a different border style in order to make my answer look nicer and more distinct. And all I have to do, if we remember, the way we add two matrices is by adding the corresponding elements. So I'm going to take the first element from the first matrix and add it to the element in the first row, first column of the second matrix. Click enter. And to simplify these computations, I'm just going to drag this cell across the rest of the cells. And just like that, I have matrix addition. I can also perform matrix subtraction the same way. I'm just going to go select the element in the first row and first column of the first matrix, subtract the element from the first row, first column of the second matrix, and repeat the same thing like I did for addition. Just like that. Let's now move on to matrix scalar multiplication. So whenever you do matrix scalar multiplication, you're just scaling all of the elements in the matrix with a predetermined constant. In this case, my scale factor is going to be 6, and I'm going to multiply every of these elements in the matrix with the number 6. Now the setup I like to use for these kinds of situation is to have a scalar factor column and a column where I put the scalar factor, and then next to it I want to put the matrix I'm trying to scale. So let's try this out. Let's take the scalar factor multiply by the element in the first row of the first column for the matrix, drag this formula across and see what happens. Now, if you notice, this result doesn't make any sense, because obviously, 6 times 3, it's not 0, right? So what went wrong? If you open this cell and highlight it, you will notice that, well, for the first entry of the matrix, the multiplication that's being done is the one we want, 6 times 1. The multiplication in the second column, first row of the matrix, it's not, because this scalar factor shifted a box. Now, to avoid such problems, we can always put the $sign operator before the letter or the column number of the cell, and what that's going to do is prohibit Excel from moving around that particular cell. In other words, it's going to keep it as a constant. So if I press enter and I repeat the same operation, I will now get the result I am after. And if you see at the cells, you see this blue cell remains constantly here no matter where I'm performing the matrix multiplication. Alright, so now let's move to the matrix multiplication where the size of the matrices actually matters. Now, to accomplish such a task, we're going to make use of the array formulas in Excel. They're just like regular formulas, but whenever you use them, you have to make a selection of a few cells and then apply what you want to do. So here we're multiplying two 2x2 matrices, and to get our answer in Excel, all we have to do is highlight the area where our answer is going to be displayed, type equals m mult. Notice how Excel automatically fills in the blank, and it basically stands for matrix multiplication. The first argument it takes is an array, so we want to select the first matrix we are multiplying, separate it by a comma, and select the second matrix. After that, we want to close the parentheses. Now, this is extremely important. Whenever you are dealing with array formulas in Excel and you want to evaluate them, you have to always press the command Ctrl Shift Enter. Otherwise, it won't work. And just to make sure we get in the hang of this, let's try one more example. So we select the area where the answer is going to be displayed, type m multiply, select the first matrix, separate by a comma, select the second matrix, close parentheses, and press Ctrl Shift Enter to evaluate. Here is our answer. Let's now tackle the matrix transpose. The matrix transpose, if you remember from the review lesson, it just swaps the rows and columns. Again, to do matrix transpose in Excel, or the transpose of any pieces of information for that matter, because as we're going to see soon, you can also have text data, all we have to do is select the range of cells where the matrix transpose is going to be applied, and use the transpose formula from Excel. Afterwards, we want to highlight the range of cells where our matrix is stored and click Enter. Pretty easy, right? The matrix transpose is evaluated. Now, let's say we had some pieces of data and we were trying to rearrange them in our worksheet in order to perhaps export them to some other program or do some particular task with those data. And we don't like the way these data are currently presented. If we want to transpose text data, we again do the same exact thing. We select the area where the transpose is going to be displayed, type equals transpose, and select the data we want to transpose. Close the parentheses, press enter, and just like that, Excel flips the row and column for the given data. One more thing for today is going to be matrix determinant. If you want to evaluate the determinant of a particular matrix, all you have to do is select the cell where you want to display your answer, type the equal sign, and type the formula m determ, and select the matrix you want to find the determinant of. Close the parentheses. And again, this is one of those array formulas, so click Ctrl Shift Enter. And the answer, by no surprise, is -2. If you want to verify by hand, you can go ahead. 7 times 10 is going to be 70, minus 9 times 8, which is 72. 70 minus 72, it's -2. Alright, so that is the application portion of the course for this particular lecture. But don't forget that I have also created exercises for you to practice the concepts we just learned, and I highly encourage you to go over them, perhaps replay the video if you have to. And if you feel that you are very stuck, you can always go look at the solution, which is located in the next tab below. Here, solution. But for this particular exercise, all I want you to do is just perform some of these matrix operations we did together. And for the last problem, it's kind of like an extra credit, if you like to view it that way. I want you to combine multiple of these arguments that we learned today in one formula and see how that works out and save space. Alright, until next time, see you then.
The first concept we need to be aware of is the inverse operation. The inverse of a matrix is basically denoted with a -1 superscript, and whenever you multiply a matrix by its inverse, you get the identity matrix. The identity matrix is nothing more than a matrix with 1s across its diagonals and 0s everywhere else. The reason we want a matrix in this form will become more apparent when we do the example I have prepared for you. And here in this picture we can see that indeed if we try out this multiplication of matrix A and its inverse, which I'm going to show you how to calculate in Excel very easily, we get the identity matrix. As always, remember that the inverse of a matrix exists only for square matrices. Moving on, we need to know what are systems of linear equations. Systems of linear equations is simply one or more linear equations that have the same set of variables. And we can have something like variable to the 1/3 or some other power or cosines or anything like that. We simply have a constant and a variable, nothing else. As we can see here, 6x plus 3y equals 33, 6x minus y equals 5. Here are our two equations. Each of them has two variables, x and y. Now, the reason we need these sort of equations is because they come naturally when we try to solve problems in uniform bodies, mixtures, finance, and you name it. As far as solving these equations, it means that we are finding some variables, in this case x and y, that satisfy these equations. And here, if I was to try randomly, by some sort of brute force method, different values for x and y, I will eventually come to the conclusion that x equals 2 and y equals 7 satisfies both of these equations. But this can be a very tedious process, because imagine you have an equation with more unknowns, then you would have to essentially try endlessly and hoping to find an answer. That's why we have developed certain methods that allow us to solve these equations. One of them being the substitution method, where we solve for one variable, substitute into the other equation, and solve for the other variable. The process of elimination, which allows us to cancel certain variables by adding or subtracting a multiple of an equation to another equation. And if we are lucky and we are dealing with 3 or fewer dimensions, we can often graph these equations and see where they all intersect. However, what happens if you have a system of equations that has something like, 5 unknowns, 15 unknowns? Are you really gonna take your time and do it by substitution or process of elimination? Well, not really. It would take really long to do it that way. That's why we use matrices, or the matrix method rather. Now, before we can use the matrix method, it is important to be able to convert this form of equation into a matrix form for Excel to understand and for us to solve. And the way we do that is we begin by first lining up our variables. In this case, I highlighted in green the x's, and as you can see they line up. And in yellow, the y's, they also line up. What we then want to do is fill out this variable matrix over here. And the first variable that goes over here is the first variable that's here in the equation. In this case, it's x, so the first variable here will be x. And then what's the second variable in order? It's y, so my second variable will be y. Again, this is important, and the order matters, the way you put these variables. Afterwards, we want to extract the coefficients from these variables, in this case 6, 3, 6, -1, put them in the matrix, and on the right hand side of the equation we want to put the constants, 33 and 5 in this case. After we arrive in this form, what we want to do is multiply by the inverse of this matrix, and if we carry out the multiplication, we're going to see that we get the identity matrix times this variable matrix equal to the solution of the system. I encourage you to try out this multiplication. You will see that multiplying by the identity matrix is like multiplying by 1. Hence, I have my solution here expressed explicitly. And to verify, we can go back a couple of slides and see that the numbers we were trying before, x equals 2 and y equals 7, are the same as we got here using the matrix method. Having that said, we are now ready to jump into Excel and demonstrate how we can solve more complicated systems of linear equations. See you there. Let's now apply the concepts we reviewed in Excel. Before we begin, I want to remind you that this Excel file is available for you to download, and I highly encourage you to do so and follow along because it is the best way to learn and retain this information for a longer time. So back to calculating the inverse of a matrix. The inverse of a matrix exists only for square matrices, and the result will be a matrix of the same size as the matrix you're taking the inverse of. So here we have a 3 by 3 inverse, and the inverse of it is also going to be a 3 by 3 matrix. That's why I begin by selecting a range of 3 by 3 cells, and I'm going to make use of the array formula called M inverse. If you don't want to type the whole thing, Excel readily provides to you the necessary command, M inverse, and it takes one parameter, and that is the matrix you're trying to take the inverse of. So I go ahead and highlight the matrix I want to invert, close the parentheses, and to evaluate I hit Ctrl, Shift, Enter. Now, what is a way to verify that the answer we got here indeed is the inverse of this matrix? That is the following identity. Remember that whenever we multiply a matrix by its inverse, we should get back the identity matrix. So let's copy here our inverse matrix we calculated, and let's carry out this multiplication in order to check whether we got the correct answer. We're multiplying a 3 by 3 matrix with another 3 by 3 matrix, so the result will be a 3 by 3 matrix. I select the range of cells, a 3 by 3 range of cells, I type equals, and then M mult, which stands for matrix multiplication. Select the first matrix I'm trying to multiply, and remember the order matters, and let's also pick the right matrix. Close the parentheses, Ctrl Shift Enter to evaluate, And indeed, what I calculated earlier is the inverse of a matrix, because here, whenever we multiply the original matrix by the inverse of the matrix, we got back the identity matrix. Now you might notice these two cells here aren't exactly 0, but that's not a problem, because 8.32 blah 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 to the negative 17 times 10 to the negative 17 power is a really small number, and so is 2.22 times 10 to the negative 16. So these two numbers can be treated as 0. Let's now combine these two concepts in order to solve a system of linear equations. Here I went ahead and extracted the variables I'm going to use, in this case x, y, z, and I did that in the order they appear, x, y, z. I also made sure that my variables are aligned. You see, all the x's are in one column, or the y's, or the z's. I then extracted the coefficients from these variables, so 18, 14, 6, 18, 14, 6, 2, 23, 9, 2, 23, 9, 7, 7, 19, 7, 7, 19, and on the right hand side of the equation I just put on the constants, 5, 9, 7, 5, 9, 7. Remember how we solve these equations? We just multiply by the inverse of this matrix, which is going to be a 3 by 3 matrix. So if I multiply a 3 by 3 matrix with a 3 by 1 matrix, the result is going to be again a 3 by 1 matrix. So I select a 3 by 1 array of cells and type equals mmult, which stands for matrix multiplication. And if you did now the previous homework I assigned to you, you would know that you can nest formulas together in order to save space and time. So let's do that. Let's find the inverse of this matrix and carry the multiplication of this inverse and this matrix in one line. So first I want to find the inverse of this matrix, close the parenthesis. So before the comma, this is the first parameter of the matrix multiplication formula. Next, I want to select the other matrix, close the parenthesis, and hit Ctrl-Shift-Enter to evaluate. Here are my answers, just like that. Now, if you're not sure whether these indeed satisfy our equation, you can always check manually with a calculator to make sure that what you have makes sense. So let's zero in a calculator and type 18 times negative 0.0371 plus 14 times 0.28629 plus 6 times 0.276613. This better gives us 5. And here we have it. Therefore, I am confident that what I have here makes sense. If you want to be more certain, go ahead and check out these other expressions to make sure they evaluate to what you want. Finally, let's review finding the determinant of a matrix. Remember, it exists only for square matrices, and the output is a single number. And the formula we use equals m determinant. We select the square matrix, close parentheses, and hit Ctrl-Shift-Enter to evaluate. Right, so this concludes the demonstration portion of Excel. Let's now take a look over the exercise I have assigned for you. In this first exercise, I want you to find the inverse of these two matrices and then verify using this identity over here, A times A inverse equals the identity matrix, to check whether you got the correct answer. Afterwards, I want you to solve this system of linear equations in the method we just learned by extracting the coefficients appropriately and carrying out the necessary operations. As always, if you feel that you are stuck, you can always refer to the solution that's here in the next tab, or you can verify your answers by hand to make sure that your answers are correct. Alright, see you in the next video tutorial.
It is just a function or a tool that tells us how fast a function is changing a particular point. In other words, it's like saying, what is the slope at this point of the function? But by definition, we need 2 points to get a rise over run. However, what happens if we get these 2 points closer and closer to each other? Eventually, these 2 points become 1 point, and we get the derivative at that particular point. And this is exactly what the formula, the limit as h approaches 0 of f of x plus h minus f of x over h is telling us. Take a point that's slightly farther away from your point of interest, subtract the function evaluated at your point of interest, and divide by that infinitesimal small step you made, rise over run. Moving on, an integral, it's for our purposes a tool that allows us to evaluate the area of a function, and we can always use the methods we have learned in calculus to evaluate integrals, but whenever we have a complex function to evaluate the integral of, we can turn into numerical methods such as the trapezoidal approximation or rectangular approximation. This tutorial I'm going to make use of the trapezoidal method since it tends to be more accurate. For the trapezoidal method, what we are doing is we are splitting the function into small trapezoids in the range we are interested in evaluating the area, and we are just adding up all those tiny trapezoids. So the area of a trapezoid, if we remember, is simply small base plus big base all times height divided by 2. And this is exactly what this formula over here is demonstrating. F of x would be here the small base, right, this length. F of x plus h is going to be the bigger base, this length over here. X plus h minus x is simply going to be this height of the trapezoid, which evaluates to h, by the way, divided by 2. Now, before we jump into Excel, I also wanted to make you guys aware of another resource that you can use to evaluate integrals and derivatives in Excel pretty easily, and that is Excel Lab 7.0. I'm not being paid by them to advertise this to you guys, but I found it useful when I was doing one of my labs for physics. So I thought I'd share this information with you as well. You basically just go to their website, they have a bunch of videos on how to use their tool. It's like a plugin, you download it, you install it in Excel, and you can do derivatives, integrals, and much more, just like you would usually do if you were using some other software. However, the beauty of this is that you're doing it in Excel, which hopefully you're more familiar with working. Let's now switch gears into Excel and start taking a look how we can actually evaluate these functions. First off, the derivative. Here I have a function x squared plus 3x. Using our calculus method, we can easily say the derivative of this is going to be 2x plus 3. And if I want to evaluate the derivative at, say, a point x equals 1, well, that's pretty simple. 2 times 1 is going to be 2 plus 3 is going to be 5. Therefore, the derivative at x equals 1 is going to be 5. But what if I had some sort of a more complicated function like secants, cosecants, e to some power, and who knows what? In that case, we resort into this numerical method, and I'm not gonna go over the formula again because we review it in the PowerPoint. But basically, what we need to do next is do a setup similar to this, because whenever you type things that are part of a big formula, it's always a good idea to break it down into smaller, manageable chunks. This way you can identify your errors earlier on and do the necessary troubleshooting. So let's try a step of 1. So x plus h is going to be, let's see, x plus h. F of x is going to evaluate basically this function at x equals 1. So let's do that. 1, okay, sorry, equals 1 squared plus 3 times 1. We get 4. And let's also evaluate x plus h for the same function. Alright, x plus h is over here. That's squared plus 3 times x plus h. We get our answer. Let's now bring it together with the formula. Equals f of x plus h, okay, minus f of x, very good, divided by h, you got it. Click enter, and the numerical answer is, as you see, not equal to the actual answer, which is 5. And the reason that is because we used a very big step. Let's see what happens if we decrease the step, make it smaller. Let's make it 0.1. You will see that the numerical answer is approaching the actual answer as we make the step smaller. And since Excel is doing all the math, you know, who cares? Let's make the step very small. And as we can see, we get almost, you know, the actual answer, which is 5. So, well done. Next, let's look at the integral of a function using the trapezoid method. What I like to do when evaluating integrals is have this setup over here where I have 3 columns. In the first column, I want to name it the name of the function, in this case x squared plus 3x. In the second column, I want to put the independent variable, in this case x. The last column, I want to put the area of every single trapezoid that I'm going to use. So here I went ahead and I graphed this function with Desmos. And say we are asked to find the integral from x equals 1 all the way to x equals 2 for this function. Again, this is not a difficult integral, we can all evaluate it, hopefully. And when we carry out the math, we get the answer is 6.833. Now the question is, can we arrive at a similar answer, or if not the same exact answer, using a numerical method? And for that, let's apply the trapezoidal formula rule from the PowerPoint. And that is as follows. Okay, I'm just making ready my parentheses. So in the first set of parentheses, I want to put the big base plus the small base. In the second set of parentheses, I want to put the height of the trapezoid, which is simply going to be x2 minus x1. And for the denominator, I just want to put 2. Click enter. Now, the nice thing about Excel is that I can create a repetitive calculation multiple times simply by drag and dropping the cell in this range of cells. Let's now sum up all these values and see whether the area we calculated using the numerical method indeed matches the actual value. And we can see that it matches to 3 decimal places, right? 6.83375 as opposed to 6.83 repeating, which is pretty good depending on the accuracy you're looking for. You can always make the step smaller and get even closer to the real answer. But for most applications, I recommend a step of 0.05. And as always, please don't forget to take a look at the homework I prepared for you. I ask you to evaluate an integral and a derivative. As always, I provided the answer for you. Alright, having that said, see you in the next lecture. Welcome back everyone. In today's video tutorial, we're going to look at conditionals in Excel and how we can implement them in our worksheets and become more productive at what we do. So to get things started, we're going to look at the if-else statements. So to construct an if-else statement, all you need to do is, like you type a regular formula, begin by typing an equal sign, type the keyword if, and Excel automatically autofills for you the formula. And the if statement checks whether a condition is met and returns one value if true and another if false. Pretty straightforward. So let's see how we can make one. The first step is to put some sort of a logical test. In other words, we want to check whether the value in some cell is equal to some other value, greater than, less than. We have a bunch of logical operators. In this case, I have an inventory of a few electronic items, and I want to check whether I have enough of them or I need to buy more. And I will define as having enough items if I have at least 3 of each kind. So let me check whether this cell is greater than or equal to 3. If this is true, then Excel will go to the first field over here and display whatever I put in this value if true field. Now that could be a text, it could be a boolean such as true or false, but it can also be a text. In this case I want to put a text, so I'm going to use quotation marks around my desired phrase, which is you have enough. And if I don't have enough, I just want Excel to display the message, you need more. And I click enter. And the message you have enough is displayed for this first row because I have 4 computers, and as long as I have 3 or more, I'm good. Therefore, this first part of the if statement is going to execute. Now, to save ourselves some time, I'm going to drag and drop this formula to the rest of the rows. And as we can see, we don't have enough monitors. And the reason that is, well, 2 is less than 3. Therefore, this if statement evaluates to false. So this message over here is displayed. Pretty straightforward. Now the question becomes, what if I want to compare several logic statements? You know, if I have, let's say, enough computers and enough keyboards, then do something. Otherwise, you know, do something else. The way we can accomplish that is with the AND statement. And inside this AND statement, we can feed multiple logic statements, like multiple comparisons. So let's demonstrate. Again, we begin by typing the equal if, since we are trying to check a condition. And right afterwards, we want to type the keyword AND. Open parentheses again. And inside this AND statement, I want to put my logical tests. Now here I have a few ingredients to make a sandwich, and say I want to check whether I have enough ingredients. So I will define enough ingredients as follows. If I have, let's say, 2 or more bread slices, and if I also have, let's say, more than 1 cheese slice, and I also have at least 1 or more ham slices, then so once we are done entering the logical statements, we want to close the parentheses for the AND statement and press comma to display the value if this evaluates to true. So if this statement evaluates to true, I want it to say you can make a sandwich. Otherwise, I want it to say you don't have enough ingredients. Ingredients. Very well. Click enter. And to our surprise, we don't have enough ingredients. And the reason that is because we have 0 ham. And for an AND statement to evaluate true, all of the components inside have to be true. So if I change this to, let's say, 2, then the if statement evaluates to true, and this first line here is displayed. You can make a sandwich. Now, what if I want to check multiple logical tests, but return true only if one of these items is true? In other words, I don't want all these tests to be true. And to our rescue comes the OR statement. It is formulated just like the AND statement, but inside, when we put multiple logical tests, only one of them has to be true for the if statement to be true. So let's check whether we have enough bread slices. So let's say we're going to define enough bread slices as being more than 2. And let's check if we also have special sauce and we have more than 1. We close the parenthesis for the OR statement. And we want Excel to display you are good if either or of these conditions is satisfied. And go to the supermarket if both of these conditions fail. So you're good, even though I have 0 bread, right? So let's now see what happens if we don't have enough special sauce either. Well, since we don't have bread slices and special sauce, then we need to go to the supermarket. This if statement evaluates to false, and this second line here is the one that's being displayed. I know this is like a simple example, so let's now look at an worksheet that I used for one of my classes to perform some calculations for the structural strength of a steel member. So in this worksheet, I have included a portion of the code I was constantly referring to when doing my calculations. And I have given a few fields for the user to input certain properties for a material. And the way I set up these conditionals here is to check which of these two formulas, and the way I determine which formula applies is simply by taking this ratio fy over fe and checking whether it is less than 2.25 or more than 2.25. If it is less than or equal to 2.25, I use this formula. If it is more than 2.25, I want to use this formula. As you can see, here is the logic as I just described. And finally, I want to use, the correct formula and do something to that number. And that something can be found over here. The next step you might want to consider now is, while displaying a message is good enough, what if you want to format a particular cell, let's say with particular font or color? This way it is more readable to you and to someone else using your worksheet. What you want to do is first select the cells by holding down Control that you want to apply this type of special formatting. And then when it says conditional formatting, you want to go to New Rule. and select the rule type, format only cells that contain. Here in this drop down box you're given several options, but in this case we're going to use the specific text option, and that magic keyword is going to be applies. In other words, in these two cells that I highlighted, if Excel sees the keyword applies, then it's going to do this specific formatting to that cell. And the formatting I want to do, I click here, format. I can change like the type of data, how it is displayed, I can change the font, I can change the border. I only want to alter the feel of that particular cell. Let's make it a nice green color. Click OK, click OK. And by magic, Excel tests which of these two boxes contains the keyword applies and formats it as I specified. Now it's more apparent to me which formula is being used for this calculation. And just to make sure that this is completely automatic, I don't have to do anything else, let's change one of these numbers over here and see that Excel automatically updates which of these two formulas apply, highlights it, and then performs the necessary calculation that I asked it to do. So I hope you guys found this video helpful and you're gonna start applying conditionals to your worksheets. This can save you a lot of time whenever you are dealing with complicated and repetitive calculations that involve a lot of conditionals and checks. Alright, having that said, see you in the next video tutorial. Welcome back everyone. In today's video tutorial series we're going to look at how we can import data from different file types into Excel and then later carry on without analysis. Now, more often than not, you will find yourself performing some sort of an experiment out in the field or your laboratory in order to determine a correlation between two variables, whether it is heat, time, I don't know, stress, strain, whatever you might be working on. And because this data, depending on what equipment you're using, like to store data in different formats, it can often be a headache trying to import this data directly into Excel. For example, I was doing this experiment where I was recording the temperature of water as I was boiling it, and the Arduino module I was using it was storing the data in this text file, in this way. Now, if I try and copy this data and paste it directly to Excel, I run into the issue that Excel doesn't recognize that these two are two columns of data, so it will just join the time data and the temperature data into one cell and repeat it for everything, which is not what I want, because I would have to now manually go and separate these two data types. Happily, to our rescue, there is a solution that allows us to import this data nicely into Excel, and that can be found under the data in the toolbar section up here. And afterwards you want to click on Get Data and click From File. Now here Excel gives you several types of file formats, text, HTML, PDF, and honestly these are the ones I find myself most commonly using. Now for this experiment my data is stored in a text file, so I'm just gonna click text/CSV. I want to load my data into the Excel, so wherever it is stored, you might want to go find it in your computer where your data are stored. Afterwards, you want to select them and click Import. So this window pops up and Excel asks you for a delimiter. Now a delimiter, it's like a special character that's in your data that's separating the data from each other. In my situation, it's simply a comma, so I'm going to use a comma. I want to leave these two fields as default, don't change anything. And just like that, if I click Load, Excel automatically splits the data into two columns and boom, the problem is solved. Now, if I want to do some more calculations or analysis with this data, it will be very easy because they are separated into two distinct columns, and I don't have to bother wasting additional time to separate. So here I made a graph showing the temperature versus time relationship. Alright, I hope you guys found this video helpful. See you next. Welcome back everyone. In today's video tutorial we're going to solve different types of equations using Excel. In this first example we have a quadratic x squared plus 2x minus 3, and say we wanted to find the places where it crosses the x-axis. Find the zeros of this function. Now you might say this is like a pretty easy quadratic to solve, right? You can just factor it, why bother using Excel in the first place? However, bear with me and you will soon find out where the power of Excel lies. So, whenever we want to solve some type of an equation, we want to have this two-column setup. We want to have a column for our independent variable, right? The variable that we are changing. And we also want to have a cell for the dependent variable. In this case, your f of x or your y. Now to save time, I went ahead and typed this formula into this cell, and I referred to x over here, which is my independent variable. Now whenever you want to find the solution of equation, all you have to do is simply go to the data section and under what if analysis locate goal seek. Now goal seek asks for three things. In the first cell you wanna put the target cell, in other words the cell that Excel is going to check to see if it arrived at the correct answer. And this cell is going to be here, my f of x. The value I want to achieve is 0. But if you want to achieve some other value, you're completely free to choose your own value over here. I just want to find the zeros of these functions. I'm going to put 0. By changing cell, here I want to put the cell that Excel is going to constantly change until it finds the solution I'm looking for. And that is going to be here, my independent variable x. Afterwards, I click OK and watch Excel do its magic. The solution is x equals 1. And if I plug in, right, 1 plus 2 minus 3, that's 0. So Excel successfully found the solution. We can use the same idea to find where two equations intersect with each other. So again, here I went ahead and typed the first equation and the second equation. But in order to check where two equations intersect, we also need to add an extra step, and that is we need to find the difference between these two values. Because if you think about it, whenever the difference between two functions becomes really small, they are essentially equal to each other whenever the difference between the two functions is 0. And again, we want to go to what if analysis, goal seek, the set cell. This becomes now our set cell. We want it to achieve a value of 0, which means we want to minimize the difference between these two functions. And the way we want to do that is by changing this cell over here. Again, click OK, and watch as Excel instantaneously solves for the problem. 1.5 is the solution. And you can see that 1.5 indeed, these two functions equal each other. Now, as I was saying, you probably wouldn't use Excel to solve something as easy as this because you can do it with your eyes closed. But I don't think you can do this with your eyes closed, right? So that's where would Excel come in. Now, as part of your homework, I want you to do a similar setup that I did before. And I want you to find the solution for this equation using Excel. As always, if you are stuck, I provided the solution to you. So give it a try and don't be afraid to fail. Alright, having that said, see you next. Welcome back everyone. In today's video tutorial we're going to look at Excel Solver, which is Goal6's older brother, and for a very good reason. It allows us to optimize systems with as many as 200 unique variables. Now Excel Solver can be found in the Data tab, here as Solver, but just in case it is not activated in your version of Excel, you can always go to File, go to your Options, Add-ins, click here Go, and check the box that says Solver Add-in. After that, click OK, and the Solver icon should appear here on the top right of the screen under the Data tab. Alright, let's now look at an example with Excel Solver. So say we have this implicit equation and we're trying to find two variables that satisfy this relationship. Now we could try and solve it. It would probably take a lot of time, and I'm not sure if you can even do this one by hand. Luckily for us, Excel Solver takes away this tedious task and allows us to find the solution to equations like these with a click of a button. So all we need to do is go click Solver. If there happens to be some sort of preset options in here from a previous problem, you can always click Reset All to clear out the window. And the first parameter it asks us is the objective. And similar to Goal6, we want to put the cell that we are interested in. In this case, it's the value of this function. Here, it asks us what we want to do. Do we want to maximize the function? Do we want to minimize it? Do we want to achieve a specific value? In this case, we want to achieve a value of 3. So I'm just going to type 3 here. And how do you want to get to this value? What cells do you want to alter? I want to alter these two cells, X and Y, so I select them. Now, depending on the circumstances of the problem, if there are certain values that are not allowed, you can always add constraints here for the cells. In other words, say you have a natural log and the value inside can be 0 or negative, then you could add a constraint like that. This way Excel Solver knows exactly how to look for an answer. In this case, I'm not going to add any constraints. I'm just going to click Solve and watch as Excel finds that these two numbers indeed solve this equation. However, don't be discouraged by what Excel Solver can do so far, because trust me, it doesn't only solve equations, it can do much more. And in the next video we're going to look at another application of Excel Solver. See you there. Alright everyone, so for the second part of this lecture we're going to look at how we can use Excel Solver in order to create a curve of best fit for some arbitrary data set that we might have collected from an experiment. In this case here I have performed an experiment for my water resources class. We were trying to neutralize a solution by adding specific amount of nitric acid, and then we recorded the pH as more and more nitric acid was added into the solution. Now you might try and go in Excel and find some sort of curve of best fit, either a polynomial or a logarithm depending on what's available, the default options, but you will soon realize that none of those actually look the way you want it to, because the actual equation that describes such an experiment, according to my textbook, is this particular equation over here. And unfortunately none of those is portrayed in Excel. Now, to overcome this problem, we want to make use of the Excel module. And the way we go about this problem is we want to have a table of at least 5 columns. Now, in the first column, we want to put our X values. In this case, my X values are going to be the total amount of nitric acid at any time in the solution. and my y values are going to be the pH of the solution at any given time. After I have that done, I want to go ahead and create this special section over here called fitting constants. And in fitting constants, I want to put down all the constants that could be changed in the equation. So if this is my equation, right, k times 1 over 1 plus c to the a plus bx plus c, the constants I can alter and get different types of curves are this k over here, this a, this b, and this c, right? So I want to make a constant for all of those. So I want to make a constant for all of these constant and equate it to a number. Doesn't matter what your number you put, as long as you put any arbitrary number for now. And after I have that done, I want to go ahead and type the formula under the column that says fitted y values. And what I did here is I went ahead and typed this equation in Excel, and whenever I was encountering one of these variables, I just referred to one of these cells over here. This way, if I change one of these numbers, the formula updates automatically. So after I have that done, I want to grab and drop this formula for all my entries in the dataset. And this is what I have so far. Now, I already went ahead for you to save you the trouble and graphed this data over here. So don't be surprised why this updated. But so far, as you can see, this is like a very bad approximation, right? Here we're looking some sort of an S-curve, and oh man, right now we have a straight line. So how do we overcome that? Now, if you want to use Excel Solver to find the optimal solution, if you want to arrive at this optimal S-curve, you want to have some sort of a metric that Excel Solver can check to see whether it arrived at the correct solution. And the way we do that is through residuals. And what a residual allows us to do is check the value we have approximated, compare it to the actual value of the experiment, and tell us whether we are overestimating or underestimating. So if I take this fitted value and subtract the actual value, I can get either a positive or negative number depending if I am under or overestimating. However, this is a problem because positive, rather overestimates that are positive numbers and underestimates that are negative numbers can cancel each other out. And when we add up all these residuals to check basically how good our function is, we might get like a sum of 0, but that doesn't mean we have arrived at the solution because these residuals just cancel each other out. So to overcome this problem, we just square every residual, like so. And now this is what we use as a metric. We add up all these squared residuals over here. And this is what we're going to try to minimize in order to arrive at the optimal solution. So once you have all your columns set up, you want to go to Data, click on Solver. For the objective, we want to use this sum residual over here. We want to minimize its value. And the way we're going to achieve that is by changing these cells here. 1, -10, 1, 1, which correspond to these variables, by the way. Choose GRG nonlinear for this case and click Solve. Almost instantaneously, Excel finds you the constants you need for this equation to work and describe in the best way possible this data. And this is our final solution, the S-curve we have been looking for. Nice. Now, I know this was kind of a lot to process, you know, the residual, the sum, and the Excel solver. That's why I want you to go ahead and try out this exercise I set up for you. I even gave you like a small hint about the type of function you want to approximate this data with. And as always, if you feel stuck, I want you to rewind the video, or if you are very badly stuck, then you can always check the solution and see what you're supposed to get as your final answer. Alright, having that said, see you next. Alright, welcome back everyone. In today's lecture we're going to look at how we can make our worksheets more user-friendly and concise so we can work more efficiently with them. And to achieve that, we're going to look at how we can use sliders, drop-down boxes, checkboxes, and how we can add comments to certain boxes. Now, if you haven't already, I want you to go to the toolbar up here, right-click, I want you to choose Customize the Ribbon, and under this drop-down menu, I want you to click on Developer, click a checkbox, and hit OK. As you can see up here in the ribbon, now the Developer tab is now enabled. This allows us to do all these good things we're about to do. Let's begin by adding some sliders. I want you to go into Insert, this briefcase icon, and under Form Controls, I want you to select this scroll bar form control. Now you can just drag and drop it wherever you like so. But if you want a nicer placement that fits into the cells, you can always hold down the Alt key as you input these sliders, like so. Right now these sliders aren't really doing anything because they are not linked with a cell, so you can just move them around but nothing is going to change. Now in this case over here I have two bodies that I know their initial velocity and acceleration. However, I'm interested to see what happens as I change either the initial velocity and acceleration for one of the bodies and see how that affects the distance it travels in a given amount of time. And to achieve that, we need to link this velocity cell with this scroll bar and this acceleration cell with this scroll bar. Now to link a scroll bar with a cell, all you have to do is right click on the scroll bar and hit Format Control. For the current value, choose, I guess, a number that is going to be relevant to your experiment. I'm going to choose 1. For your minimum value, you want to put something equal to or greater than 0. And for your maximum value, again, whatever it's reasonable for your experiment. You can leave those as default, but basically the incremental change tells you how much every time you slide the slider by 1 unit, you know how much should the cell value increase or decrease. The important cell is the cell link. Here we want to click at the cell that we want to alter using that scroll bar. With this first scroll bar I want to alter here the velocity cell, so I'm going to click on here and press OK. Now as I drag this slider across, you can see how the graph is changing over here. Just for practice, let's repeat the same procedure, but this time for acceleration. Again, I will leave the maximum value as something that's reasonable for my experiment and link it to the appropriate cell. Click OK. And now I can also alter my acceleration. The faster it accelerates, you know, the more distance it travels in a shorter amount of time. Now this is a very easy, I guess, experiment to study, but I just want to demonstrate the idea of why we can use sliders. Let's now see how we can create a drop-down box and why you might need one. Now say we have like an inventory of items. In this case, it's a list of shapes. And instead of having them, in my worksheet lying around everywhere and making a big mess, it would be much nicer if I could, for example, just click somewhere, see like a drop down of all these available shapes in my inventory and select one. Now, to achieve that, we want to go into data. We want to click the cell where this drop-down box is going to be created. So I went ahead and merged these cells over here for your convenience. I want to click on this cell. And after that, I want to go under data validation. And let's just press on data validation. I want to go into input message. No, I want to go into settings. After I open up data validation, I want to go into list. Let's disable this ignore blank. And for the source, we want to select the list of available items in our inventory and press OK. Now, as you can see, this little symbol popped up over here, and that indicates that this cell is a drop-down box. So if I click on this, I can select any of these shapes, without having to view them over here and take up unnecessary space. Moving on, let's look at checkboxes. So now, say you wanted to make some sort of a game within your worksheet, or like a formula where you get to choose certain parameters, and you can do so by clicking on them. Now, if you want to create a checkbox in Excel, all you have to do is go again to the Developer tab under Insert, and afterwards I want you to select here the checkbox and place it wherever you want to within the sheet. And as you can see now, if I press on this box, a tick mark pops up, and if I press again, the tick mark disappears. So far, this might not be very useful to you. However, we can make it useful by having some way of checking whether this checkbox is checked or not. And the way we accomplish that is by right-clicking on the checkbox, going to Format Control, and we want to link this checkbox with a cell. Let's link it with this cell over here. And the reason we do that is because we want a cell that displays whether this checkbox is checked. Okay, so if I check on this checkbox, this cell value will become true. And if I uncheck it, false. So I have a way of actually telling whether this checkbox is checked. So let's now make like a game. So say we have like certain options over here, option 1, option 2, option 3. Let's accordingly make a few more choices here. So another checkbox. I'm gonna place it over here. And let's make another checkbox for the third option. And I wanna place it over here. As always, don't forget to link these checkboxes with a cell. So I'm gonna link this checkbox with this cell, press OK. I'm gonna link this checkbox with this cell over here, press OK. Just to make sure this works, let's experiment a bit. Perfect. Okay, so now let's say we wanted to display some message in Excel if we made the correct choice. And to display that correct message, we wanted to check whether we selected the correct option. The way we can do that is using an if statement. So if you recall your if statements, you can always type equals if to create a conditional in Excel. And what we are checking is if this cell value over here, which is linked to option 3, if this is, let's say, true, then we want to display the message, I don't know, congratulations. Otherwise, we want to display the message, try again. Let's put a quotation mark in here. Let's also put an exclamation point over here. Right, press enter. And as you can see, this cell evaluates to try again because this checkbox is not clicked. If I click any of these other checkboxes, this cell will not change. It will still remain with the message try again. However, the instant I check the correct box, the cell value changes to congratulations. So pretty neat. Finally, let's look at how we can add comments to our boxes. This way, whenever someone else other than us is reviewing our workbook, he or she can easily get used to it and perform the necessary calculations. So it's a comment box in Excel will look something like this. You will have like a red triangle on the top right corner, and whenever you hover over it, it displays a message. That's pretty simple to do. You just find the cell where you want to display a message, right click on it and create new note. Type whatever for your note and just click away for the message to be applied. Now if I hover over this cell, it says type whatever. Alright, see you next. Welcome back everyone. In today's video tutorial we're going to look at the Vlookup function and how it can simplify our worksheets and make searching of items in a database much quicker. First things first, why would you like to use the Vlookup function? The Vlookup function allows you to quickly type the name of a particular item in a dataset, and then it will extract certain properties for that particular name that you typed. So to demonstrate this example, here I went ahead and downloaded this table of a few random movies from the internet, and alongside them I have a few details such as their gross profit, their release date, the distributor, and some other details. Now, wouldn't it be nicer if I could just type the name of the movie I wanted to know specific information about, and Excel gave me that piece of information that I care about? Now, to do this, you want to make sure that your table is sorted in an ascending order. And your search parameter, that is the thing you're going to type, in this case the movie, make sure that column is on the leftmost hand side of the table, as I have it set up over here. After that, you will also need a cell where you're going to type your search parameter, and you're also going to need a cell where the result about that search parameter is going to be displayed. So let's get to it. We click on the search result box and type equals Vlookup. Now the Vlookup formula takes three parameters. The first one is the value we are trying to look up from the table. Now you could put some thinking quotation marks over here, or you could directly link it into a cell where you can just type any parameter you want to look up. So we're going to do that. We're going to link it with a cell. The next thing that the Vlookup function requires is a table array, and that is your database of information. So I'm going to start from up here and select this whole table all the way to the end. The final parameter is the particular column you want to extract from a row. So let me explain. Say you wanted to know the distributor of the movie Finding You. Well, the distributor is located in the first, second, third, fourth, fifth, the sixth column. So if I type 6 here, what Vlookup is going to do is, well, find the movie Finding You, and then it will go to the sixth column in that row and retrieve that information that's stored in there. So let's close parentheses and see that in action. Okay, let's type the name of the movie we want to know the distributor. In this case, it's Finding You. And instantaneously, Excel gives us the distributor of the movie as roadside attractions. So pretty neat. Now, this was like a simple example, but let's now take this to the next step and see how we can use it for one of our projects to simplify our worksheets and make calculations flow more smoothly. So in this example, pretend we're doing some design work for a particular firm, and that firm has a database of different beams, and each of those beams has like specific properties that we have access to. In this case, it's like 166 columns of information for every particular beam. Now, say we wanted to look up some particular beam and extract some information, let's say like the area of that beam, the depth of that beam, and the weight of that beam. Why not? Now, you could go back to that database and extract the information you need, but wouldn't it be nicer if you could just have some sort of like a drop-down box where you locate the item you're looking for, click on it, and then Excel automatically grabs these pieces of information that are relevant to you. Now, to do this, we're going to again briefly review on the previous lesson, which was where we made a drop box. And as always, we can make a drop box by selecting a cell where we want the drop box to appear. And then we want to go into the data section in the toolbar, click on data validation, and where it says allow, we want to click on the list and uncheck the ignore blank checkbox. For our source, we need to go back to the database where the information, or rather where the names of the particular beams are located, and we want to select them, like so, and press OK. Now, if I press this cell, a drop-down menu appears, and I can select the name of the beam that interests me. In this case, let's just pick the first one, W10 by 100. Now, as far as extracting the information, such as the area, the weight, and the depth of that beam, we're going to make use of the Vlookup function one more time. Now, apart from sorting the values in an ascending order, I also find it useful to enumerate the columns in my database, because, for example, if I want to extract some information from a particular row, Excel only gives me letters for that row. It doesn't give me a number, which is something I can use. So once we have that done, we want to go back into the worksheet where we have our setup. So let's begin again by typing the Vlookup function. The first parameter is the lookup value, and that is going to be the item that we selected from the drop-down menu box. For the table array, we're going to select all of the like so. After that, you want to press, we want to add a comma, and put the column number that corresponds to that property that we are interested in. In this case, we are looking for the area. Area is the 6th column. I'm going to put a 6. Close the parentheses and press enter. Now remember the name of this beam, W10 by 100. And if I go to the database, W10 by 100, and I look for the area, 29.3, is the same thing, 29.3. So what if I'm doing some sort of iterative design until I find the best solution that works for my problem, and I want to try some other beam? Well, I can just locate it in the drop-down menu box, and Excel automatically pulls out that information that I care about, which is the area in this case. Let's do it one more time or two more times or so we get comfortable. Now, if you typed it once, to save some time, you can always just copy paste that formula, apply it to the other box, and just change this last number, which is the column number. In this case, I want to know the weight, and the weight is this big W over here, and that's the 5th column. So I'm just going to change this to a 5, press enter, and boom. What if I want to know the depth of that column? Again, you can just copy paste the Vlookup function and change this column number to the column that corresponds to depth. In this case, D corresponds to the 7th column. So I just change this into a 7, and I'm done. Pretty simple, right? Alright everyone, this marks the end for this video tutorial about Excel.